Hi, this is Mrs. Basin. Today we're going to go over the calculations for the analysis of hydrogen peroxide lab. So here is a sample data table. So yours does not have to look exactly like this, but this is the data that you collected. Let's say that I used sample 5. So there was no sample 5, but let's say I had sample 5. And this is some data you would collect before you were able to do calculations. So the first thing you have to know is what is the molarity of the MnO4 minus, which is the KMnO4. This is the potassium permanganate. This is the purple stuff that you put into the burette. So our standard solution for permanganate was 0.020 molar. So that was the same for everyone. That's the solution that you know the concentration of, that you're using to figure out the concentration of the unknown solution. So the hydrogen peroxide is what we're analyzing. That's what we're trying to figure out what the concentration of that is. So the amount that you use for your trials kind of depends on how you measured. The lab suggested you use 1 milliliter, so that should have been measured with a volumetric pipette. If you didn't use exactly 1 milliliter, then I think we talked about writing down exactly what you used. So I'm going to assume that I used exactly 1 milliliter for both of those, and notice that I'm writing down that extra significant figure. So it measures to the 10th place, so we're estimating 1 place past that. So then this third piece of information is how much of that permanganate did you need to reach the equivalence point? So how much did you need to add to that hydrogen peroxide that was in the flask at the bottom to get that really, really pale pink color? Because like we talked about, the permanganate ion is changing oxidation states from a +7, which is that deep purple color, to a +2, which is that real light pink color. So this is how much you added to it to get it to change that color. So let's say for what we're doing here, let's say it took me 17.85 milliliters the first trial, and it took me 16.50 milliliters for the second trial. Again, notice I'm writing down that extra significant figure there, or that extra figure there, because the burette's measured to the 10th place, so I'm estimating 1 place past that. So you have to make sure you're recording that information. Okay, so that's the information you need before you can start your calculation. So this is the same for everyone. This first one is the same for everyone, the permanganate concentration. The amount is going to depend how you measured. If you measured exactly 1, then use 1. If your measurements were a little bit different, just make sure you use the exact one, exact measurement that you measured out. And then again, this is how much permanganate ion you needed in order to get that pale pink color. Okay, so then to do our calculations, I'm going to go through a sample calculation for the first trial, and then I'll give you the calculation for the second trial if you want to practice that before you go to do your own. So what we're going to do here is we're going to start with the amount of potassium permanganate that was required to reach the equivalence point. So I'm going to go back to my data from trial 1, and it took me 17.85 milliliters of MnO4 minus, and again that's the potassium permanganate, to reach the equivalence point. So what I'm going to do first, I'm going to get rid of my milliliters. So 1 liter is 1,000 milliliters. And then I'm going to use the molarity of the potassium permanganate to get from liters to moles. Because once I'm in moles, then I can do the mole ratio to get from moles of permanganate to moles of hydrogen peroxide. So my potassium permanganate was 0.020 moles per 1 liter of solution. Okay, so milliliters is canceled, liters is canceled, and now I'm in moles. So now that I'm in moles, if you remember from stoichiometry, now you can change to something else in that equation. So my mole ratio is 5 H2O2 for every 2 MnO4. So the MnO4 is what I'm trying to get rid of, so that goes on the bottom. So there are 2 moles of MnO4 minus used for every 5 moles of H2O2 used. Okay, so since the next data table is asking for moles, I'm going to stop there. So when I do that calculation, I get 8.930 times 10 to the negative 4th moles of H2O2. Okay, so again, I'm using stoichiometry here, converting milliliters to liters, liters to moles, and then moles of permanganate to moles of hydrogen peroxide. Then once I have moles of hydrogen peroxide, I'm going to take that down to the next level here, so 8.930 times 10 to the negative fourth moles of H2O2. I can now convert it to grams of H2O2, which is the next thing it asks for. So for every 1 mole of H2O2, that is equal to 34.02 grams of H2O2, and that's just the molar mass. So this is just a molar mass conversion to get from moles of H2O2 to grams of H2O2. So if I do that calculation, I end up with 0.03036 grams of H2O2. Now, since my end goal here is to figure out the percent, because that's what we're comparing to, and that's what you have to report back with, we want to know what percent of that hydrogen peroxide solution is actually hydrogen peroxide. So then to do a percent, we have to take the grams of H2O2 in your sample divided by the total grams of sample that was tested. So in your lab, it tells you that the density of the hydrogen peroxide is equal to 1 gram per milliliter. So we're going to assume that 1 gram of hydrogen peroxide equals 1 milliliter of hydrogen peroxide, or vice versa. So then we're going to start with 0.03036 grams. That was what was in our sample, that's what we just calculated, divided by 1 gram of H2O2 that we analyzed. So this number on the bottom is going to be the grams of sample that you analyzed. So this is the milliliters, and since 1 gram equals 1 milliliter, I'm just changing that unit to grams there. So you're going to take grams in your sample divided by total grams that you tested times 100, and that's going to give me a percent. So if I do that calculation, I get 3.036% hydrogen peroxide. So that's really close to the 3% that it's supposed to be. So this is my results table. So I said I had sample number 5. So in that first trial from the calculation I just did on the previous screen, I had 8.930 times 10 to the negative fourth moles in the sample that I analyzed. When I converted that to grams, I had 0.03036 grams. And then when I did the calculation, the mass percent calculation to get the percent in the sample, I had 3.036% H2O2. Now if I went through and used the trial 2 numbers, then I end up with 8.250 times 10 to the negative fourth moles. For my gram sample, I would have 0.02807 grams, and then when I do the percent calculation, I would have 2.807%. So then, once you have your 2 trials and you get your percents, then what you can do is you can average those percents for your final number that you're going to report. So if I average those, I get 2.922%. So then that's the number you would compare to the standard. So does that fall within the range that it is supposed to? And then that's how you make your decision on what you're going to report back when you do your final lab report.